And next is the affection of the soil resistance. We know that because of the proportionality relationship, F and V, they should meet each other. But if they meet a soil resistance, they will separate. And the distance they separate is exactly the soil resistance, Ri. And here is the how the soil resistance separates the force and velocity. And actually, we have discussed it before. Here we explain again. At the location of the soil resistance, half of the soil resistance will go up as a compression wave. So the compression wave half Ri, we know that compression wave is positive. So half Ri compression will make the force curve go up with the magnitude of half Ri. And in wave up, we know that force and velocity, they have opposite sign. So compression wave will generate a velocity with the sign of negative. And the magnitude is half Ri divided by z. And on this plot, we times z again. So the magnitude is also half Ri. So that makes the velocity curve go down with the magnitude of half Ri, right? So the force and the velocity, they will separate with the distance of Ri because of the soil resistance. And this is how the soil resistance works on the F and V curve. On wave up curve, we can see here, this value actually is the shaft resistance. Actually, it's half of the shaft soil resistance. Of course, it includes static and dynamic soil resistance. And at the time of 2L over C, this means the toe resistance. So from this, the wave up plot, we can get the idea how the capacity is consisted. And from the slope of the wave up, we can also get the idea of the magnitude of the unit shaft resistance. Take this for example. For this area, the wave up plot is almost flat. So that means there is almost no shaft resistance here. And for this section, the slope is medium. Is medium. So that means the shaft resistance is medium. But for this one, it's very sharp. The slope is very high, so that means the shaft resistance in this area is very high. So that's why it makes the wave up go very fast. And this means the half of the total shaft resistance. Of course, it includes static and dynamic shaft resistance.